త్రివిక్రమ్ గారి కెమిస్ట్రీ క్లాస్లో ఇప్పుడు చిన్న బ్రేక్ తీసుకుందాం. బ్రేక్ తర్వాత స్టైకోమెట్రీ టాపిక్కు సంబంధించి మరిన్ని అంశాలను తెలుసుకుందాం.
ఇంజనీరింగ్ కాలేజ్ హైదరాబాద్, నెల్లూరు మరియు గూడూరు. నెల్లూరు మరియు గూడూరులలో ఇంజనీరింగ్ కళాశాలలు స్థాపించి ఇంజనీరింగ్ విద్యా బోధనలో 13 సంవత్సరాల అనుభవం కలిగి ఈ విద్యా సంవత్సరం నుండి అదే పరంపరలో హైదరాబాద్ లో కూడా నారాయణ ఇంజనీరింగ్ అండ్ టెక్నికల్ క్యాంపస్ కళాశాలను ప్రారంభించిన నారాయణ అత్యధిక డాక్టరేట్స్ కల అధ్యాపక బృందంచే విద్యా బోధన యూనివర్సిటీ స్థాయిలో ప్రతి సంవత్సరం గోల్డ్ మెడల్ సాధిస్తూ నంబర్ 1 గా నిలుస్తున్న నారాయణ హెచ్సిఎల్, ఇన్ఫోసిస్, ఐఓపిక్స్, యూనిసిస్, ఆరకిల్, ఎస్ఏపీ వంటి ప్రముఖ టాప్ మల్టీనేషనల్ కంపెనీలతో ఒప్పందం కుదుర్చుకుని అత్యధికంగా ప్లేస్మెంట్ సాధించడం ద్వారా అవార్డ్ ఆఫ్ ఎక్సలెన్సీ పొందిన నారాయణ ప్రతి సంవత్సరం 100% ప్లేస్మెంట్స్ టార్గెట్ దిశగా ముందుకు సాగుతున్న నారాయణ నేషనల్ ఇన్స్టిట్యూట్ ఆఫ్ టెక్నాలజీకి దీటుగా ఇంటర్నేషనల్ స్టాండర్డ్స్ కలిగిన ఇన్ఫ్రాస్ట్రక్చర్ ఫెసిలిటీస్ మరియు వెబ్ బేస్డ్ అనాలిసిస్ తో కూడిన స్టూడెంట్స్ సింక్రనైజేషన్, టెక్నికల్ ఫోరమ్స్, స్పోర్ట్స్ అండ్ కల్చరల్ ఫోరమ్స్ మరియు R&D సెల్ ద్వారా కో కరికులర్, ఎక్స్ట్రా కరికులర్ యాక్టివిటీస్ ను నిర్విరామంగా కొనసాగిస్తున్న నారాయణ హైఫై స్టాండర్డ్స్ తో వైఫై సదుపాయాలు మరియు అధునాతన వసతులతో కూడిన వేరు హాస్టల్ వసతి. హైదరాబాద్ లోని వివిధ ప్రాంతముల నుండి నారాయణ ఇంజనీరింగ్ కాలేజ్ కు స్పెషల్ కాలేజ్ బస్ సౌకర్యం కలదు. అడ్మిషన్ల కొరకు సంప్రదించండి. నారాయణ ఇంజనీరింగ్ అండ్ టెక్నికల్ క్యాంపస్, రామోజీ ఫిల్మ్ సిటీ దగ్గర, హైదరాబాద్.
ఆఫ్టర్ బ్రేక్ వెల్కమ్ బ్యాక్ టు కెమిస్ట్రీ క్లాస్. స్టైకోమెట్రీ టాపిక్ గురించి మరికొన్ని అంశాలను త్రివిక్రమ్ గారి ద్వారా తెలుసుకుందాం.
I'll give one small question. In that, try to put as comfortable expressions as possible. Look at this. I brought one sample of sodium hydroxide. A sample of sodium hydroxide is brought. In this sample of sodium hydroxide, we don't know how much real amount of sodium hydroxide present, but we want to analyze that, for which we can take help of some known acid, a sulfuric acid, hydrochloric acid of certain good known concentration. Now by using that, I want to find what is the percentage purity of this. Say in analysis it is found that a sample of this, say 1 gram of sample required exactly to neutralize some 20 ml of some 1 molar sulfuric acid, like information given. What is the information found? 1 gram sample required 20 ml of 1m sulfuric acid. 20 ml of 1m sulfuric acid is equivalent to certain amount of sodium hydroxide, and that amount of sodium hydroxide only should be present in this compound. So like that, from the chemical equation concerned, we can tell what is the purity of this. Then the reaction first you see, sodium hydroxide 2NaOH plus sulfuric acid H2SO4 give the salt like sodium sulfate, like that a chemical equation will be concerned. And how to balance etc. we know. But after looking at that balanced chemical equation, now we use this information and understand by calculation that how much is the purity of sodium hydroxide. Let us see here. It is equation saying that 2 moles equal to 1 mole of sulfuric acid. Now, in this example, 20 ml of 1m sulfuric acid you took, bound to consume to react exactly with the sample of 1 gram of that sodium hydroxide. Here, we want to analyze the sample of sodium hydroxide and 1 gram of the sample taken and found to react exactly with 20 ml of 1m sulfuric acid. Now, reaction equation, what? This is the equation between them. And when you got the balanced equation, what we want to do here is, by applying this, we calculate and find what is the real amount of sodium hydroxide in this. So let us say it is some X% NaOH is present in the sample. Here what I said, percentage of sodium hydroxide is X. If so, how do we find that X value using this chemical equation? Simple. Chemical equation says 2 NaOH moles correspond to 1 H2SO4 mole. Therefore, in this reaction, because 1 gram sample he took, X% NaOH I am assuming to be present in that. So, what is X% in 1 gram? That is the amount of sodium hydroxide. And so, for that, I will put calculation here. X% of 1 grams of sodium hydroxide present. When X is the percentage and 1 gram you took, the amount in grams of sodium hydroxide is so much. Then I convert that into moles divided by 40. Why 40? Sodium hydroxide's molecular weight is 40. So, weight of sodium hydroxide in grams divided by 40 moles of sodium hydroxide. Next, sulfuric acid. Sulfuric acid he found in the reaction that it is 20 ml consumed by this sample. 20 ml means 20 into 10 power minus 3 liters. Liters is the volume of sulfuric acid and its molarity taken is 1. Molarity into volume in liters is nothing but moles number. So, what is the expression here? Directly in the percentage, what you want to find finally is X. X% in 1 gram sample, so many grams sodium hydroxide by its molecular weight, so many moles sodium hydroxide, and it is 20 ml solution of molarity 1. So, it is so many moles sulfuric acid. Moles of sodium hydroxide, moles of sulfuric acid must be reacting in what ratio? Look at the equation, 2:1. So, this is equal to 2:1. Therefore, what is that? Whatever you want, X. Therefore, whatever the value of X you can find. So, like that, in the calculations, the percentage of sodium hydroxide really present in the sample wanted, but further an experiment is carried out, and in that experiment found that 1 gram of the sample exactly reacted with 20 ml of so and so sulfuric acid solution. When it is reacting with so many sulfuric acid solution, obviously from that we can understand moles count and also expressing that into requirement in moles, in equivalence, whatever the way we want. Here moles I took, mole ratio is known from chemical equation. So, in stoichiometry, when we want to analyze any substance, we use the chemical equations, but to apply this more and to understand more and to make it more strong in mind how to use this stoichiometry, we need certain examples, and in these any type of numerical calculations can be done based on chemical equations. And to improve our efficiency of handling stoichiometry, we can do certain improved examples, but before that one should be very clear that it is mainly in moles ratio between substances. In a chemical equation, when you see numbers like 2, 5, 1, 2, etc., we should mean them, not moles number, the ratio in moles in which they are interacting. So as long as taking them as a ratio in application, we always find it better and better. And in certain better applications of stoichiometry, we find when gases are present, pressure variation or volume variation, or sometimes even the composition of the mixtures variation. In all these, the stoichiometric calculations is again based on the balanced chemical equations only, but handling that becomes better and better depending on situation. Suppose when we want to take one gaseous reaction, say a gas like PCl5 gas decomposes to give PCl3 gas, Cl2 gas, or some other example I give here, ammonia gas. When ammonia gas decomposes, it gives nitrogen gas and hydrogen gas. These are all corresponding balanced equations for them. In these stoichiometric reactions, in every chemical equation, same thing. It is between two reactions.